Assalamualaikum and hi. Today our group will be presenting the Smart Parking Management System under CSC404 Programming 2. This is our group members, me Nur Fakira Alisa binti Nasruliza, Nur Noha binti Nur Hisham, Nurul Najiha binti Abdullah, and Muhammad Irfan Ishraq bin Muhammad.
So, my team choose to build the Smart Parking Management System for this group project. So, I will go to introduction. This project presents the Smart Parking Management System, a console-based application developed in C++ programming language. It simulates the daily operation of a real-world parking facility, including vehicle entry, exit, and reservation management. The system manages parking slots across the three zones, A, B, and C, each with a different hourly rate. So that means for zone A, zone B, and zone C have a different price. It incorporates fee calculation, overstay penalties, and a loyalty discount system for returning customers. All data is stored and retrieved using file handling, ensuring information is retained between program sessions. The project applies core C++ concepts such as structure, array, 1D and 2D functions, and file input and output. So I will give to my teammate to continue. Thank you.
Moving on to section 2, let's look at the core problem statement that drove the development of our project. Firstly, the core challenge. Urban areas constantly face massive parking challenges, primarily due to ineffective slot allocation and tracking system to manage vehicles entering or exiting parking slots. In traditional parking environments, drivers are forced to manually cruise around looking at vacant spots, which directly increases unnecessary traffic congestion. Second, without the automation, tracking parking availability and handling payments become incredibly time-consuming and highly error-prone for both drivers and management teams. Third, to solve these exact friction points, our smart parking management system was built. It is designed to seamlessly manage vehicle details, optimize parking slot allocation, automatically calculate fees, and generate comprehensive reports on slot usage statistics. Moving into the technical implementation, let's look at the section 3, which covers our program source code. Starting with section 3.1, the printed input file. To make our system highly flexible, we designed it with a dedicated reading and parsing function that handles data input from an external file. The main benefit of this approach is that data changes dynamically based on user modifications. This means we don't have to manually rewrite or hardcode the data recursively every time a change is made. Next, to manage this data efficiently, a structured data type was used. This allows the system to dynamically track crucial vehicle and parking variables such as license plates, lot capacities, calculated fees, available slots, and total hours parked. Finally, by leveraging multiple classes within our code, the system automatically processes this incoming data to generate a detailed report. As you can see illustrated on the right, the system organizes and splits the parking lot slots equally across three distinct zones that we have set, which is Zone A, Zone B, and Zone C. Next, let's look at the actual code behind our data setup, focusing on the load data function. Essentially, this function acts as our system startup manager. Its primary job is to prepare the file before any cars even arrive. First, it checks if our data file exists. From there, it runs a loop that preloads 9 default parking slots into the system and pairs them with their standard pricing rates that we have set. As the result, once these 9 baseline slots are generated and saved, the file closes safely, leaving the system completely ready to track real-time parking. Now, let's talk about the expected screen that user interact with when running the program. So, as for the main menu, when you first run the program, you are greeted with a straightforward main menu. This gives users all their core options in one place: parking a vehicle, searching for a vehicle, processing an exit, managing reservation, or viewing reports. Whenever a vehicle is successfully parked or searched for, the system doesn't leave the user guessing. It brings up a clear confirmation screen displaying the exact slot number, the zone, the license plate, and the entry time. As for the exit receipt, when a vehicle exits the slot, the system automatically generates a formatted parking receipt. This breaks down the entire stay, showing the total duration, the base charge, any applicable discounts or penalties, and the final amount due. On the left, you can see the main menu interface that displays right when the program starts. It categorizes everything cleanly into 3 sections: vehicle operations, reservations, and reports, making it very straightforward for an administrator to navigate. On the right, we have a quick demonstration of what happens when a user selects choice 2 to search for a vehicle. By simply entering a license plate like ABC1334, the system instantly pulls up a formatted confirmation box. This box immediately provides all the critical data: the exact slot and zone location, the occupied status, the precise entry time, and even the number of visits for that specific vehicle. Finally, let's look at the output generated when a vehicle exits the parking lot. When an operator processes a vehicle exit, the program triggers a function called display receipt. This generates the digital receipt you see on the screen. The receipt lists all the key information for the driver, including their slot, zone, duration of stay, the hourly rate, and the final total fee calculation. At the very bottom, you can also see that the system automatically updates the file in the background. It clears the parking slot so it becomes available for the next car, and seamlessly saves all the transactional and loyalty data to external text files. Moving on to section 3.3, the printed output file. Our smart parking management system automatically generates a full report called parking.txt. This report summarizes 3 main things. First, all parking slot records, which shows each slot status, the vehicle's plate number, entry and exit time, and the amount charged. Second, it shows the zone occupancy and revenue statistics, broken down by zone A, B, and C, including how many slots are occupied and the total revenue collected per zone. Third, it includes a list of loyalty members, showing how many times each customer has visited and their total spending. Lastly, this report can be exported at any time through menu option 11, so the parking manager can review the system overall performance without even running the whole program. Moving on to the section 3.3, let's look at the printed output files generated by our system. When an admin selects the export option from the main menu, the program automatically compiles all active data and saves it into a text file named parkingreport.txt. As you can see on the screen, the report is cleanly formatted into sections. The top section shows the real-time status of every individual spot, while the middle section breaks everything down by zones, tracking exactly how many spots are occupied or reserved alongside our total revenue. And finally, the bottom of the file tracks our loyalty updates, giving management a quick overview of the most frequent visitor metrics.
Now, let's move on to the section 3.4, File Input Output. In this program, all file input and output operations are handled using 2 stream classes. The first one, if stream, for reading data, and off stream for writing data to text files. We have 3 main functions that manage this process. First, load data function. This retrieves existing record when the program starts, so nothing is lost between sessions. Second, save data function. This writes updated record back to the file after every transaction, making sure our data stays persistent. And the third one, write report function, which is separate from the other 2 function. It generates an exportable summary report only when the user requests one. Let's look at the load data function in more details. This function takes up in the array of parking slots a reference to the slot count, the loyalty records array, and a reference to the loyalty count. The first thing it does is try to open the data file using an if stream. If the file doesn't exist yet, meaning this is the first time the program is running, it creates a new one using off stream. Inside that block, we set up 2 arrays, one for the zones, which is A, B, and C, and one for the hourly rates tied to each zone. A loop then runs through 9 slots, writing a default entry for each: the slot ID, its zone, and its rate, with a placeholder for the rest of the fields like license plate and visit count. Once that's done, the file is closed, a confirmation message is printed, and the file is reopened for reading, so the rest of the function can load that data in. Now that the file is guaranteed to exist, the function reads from it. A while loop runs as long as we haven't hit the maximum number of slots, pulling in each field in order. I've give you examples such as slot ID, zone, occupancy, reservation status, license plate, entry and exit times, reservation date and time, hourly rate, amount due, and visit count. Notice that the is occupied and is reserved fields are stored as integers in the file but converted back into booleans here by checking if they are equals to 1. They also clean up logic. If a field like license plate or entry time was saved as a placeholder dash, it gets reset to an empty string instead. Once all slots are loaded, the file closes and we print how many slots were loaded. The functions then repeat a similar process for the loyalty record, opening the loyalty file and if it exists, reading in each customer's license plate, total visit and total amount spent before closing that file and confirming how many loyalty records were loaded.
For this part of our project, we use a struct. We created two structs. The first is called parking slots and it stores everything about one parking slots like the slot ID, which zone it's in, whether it's occupied or reserved, the license plate, entry and exit time, the hourly rate, how much is owed, and how many times that car has visited. The second struct is loyalty record, which is simpler. It just tracks a customer's license plate, how many times they have visited, and how much they have spent in total. This is what lets us give discount to returning customers. So basically, instead of managing 10 different variables per car, we just create one parking slot and everything's bundled together neatly.
I will continue program source code 3.6, which is array. For the first array, we use on a parking slot and loyalty record. For the parking slot with a maximum capacity of 50 slots, is used to store all parking slot data during program execution. For the second, which is a loyalty record with a maximum capacity of 100 entries, store loyalty data for returning customers. For 2D array, we use on a store zone level statistic, including total slot, occupied slot, and revenue for each zone. So this is a array that we use on our project. On a parking, we use on a parking slot, loyalty record, and zone. Parking slot, slot, max slot. Loyalty record, loyalty, max loyalty. Integer count, integer one count. Float, zone summary, zone, and zone statistic. So I will pass to my teammate to continue the program source code. Thank you.
So this is the program source code for array. To keep our code organized, we broke the program down into smaller functions instead of writing everything in one giant block. We have functions like manage vehicle for parking or removing a car, search slot for finding a car by plate number, and process exit for handling when a car leaves. Then we have calculation functions like calculate fee, calculate penalty, and calculate charge. These handle the maths that working out to the parking fee, any overstay penalty, and applying loyalty discounts. For output, we have display functions like display menu, display slots, display reports, and display receipts. These are what brings things neatly to the screen for the user. And lastly, we have input validation functions that check the user type things correctly, like making sure the time, date, zone, and plate number follow the right format before we accept it. Breaking it into functions like this made our code easier to test, debug, and reuse, instead of repeating the same logic everywhere. So this is the function prototypes declared in the program, grouped by data handling, reservation management, fee calculation, and display functions.
So I will continue for a demonstration for our program. So we run. So this is our coding. So this is our interface. For one, we have a park vehicle, 2 search vehicle, 3 process vehicle exit, 4 for a delete record. Next, for a reservation, we have a 5 for a make reservation, 6 for a cancel a reservation, 7 for view all reservation. Next, we have a report. For 8, we view all slots. For 9, zone summary report. 10, loyalty member report. 11, to export full report to a file. And 0 for a exit. So we choose one. We park a vehicle first. So I choose a B zone. So license plate, we put a CEK 7271. For entry time, we must put a HH and MM for hours and minute. So we put a 08:30. So after we input, it will display vehicle parked successfully. Slot 4, zone B, rate CEK 7271, entry at 8.30. Rate is 30 ringgit and 50 cents for a zone B for 1 hour. So after that, we try search a vehicle. We do license plate CSC404. So have a it display have a parking at our system. Slot 4 zone B, status occupied, and entry for at 8.30. So after that, we process the vehicle exit 3. So license plate is CEK7271. Exit time at 7. 7 is 19. So so release a parking receipt. Slot 4 zone B, plate CK7271, entry at 8.30 and exit at 7. Duration is 10.5 hours. Rate is 3 ringgit 50 cent per hours. So total fee is 36 ringgit and 75 cents. So if you want to make reservation, we choose 5. We put a license plate is VDX 727271. So reservation date at we choose 11/07/2026. So reservation time is 8:30. So this is after we make a reservation. Zone A, license plate is VDX 7271. Reservation date on 11/07/2026. Reservation time is 8:30. So reservation successful. So we go to reports. So we choose 8. So this is all the slot. The CK7271 is not appear because of we already exit. So for this, for next day, 11/7 July, we have a reserve car, which is a VDX 7271. So rate is 5, amount is 30. So we need to export full report to a file. We choose 11. So we go to our file. We go to a parking report. So it will display. So this is a total car that already visits.
In conclusion, the Smart Parking Management System successfully automates slot allocation, fee calculation and report generation for a small-scale parking facility. The system demonstrates the practical application of core C++ concepts, including struct, arrays, function and file input and output applied to a real-world problem. Through the use of file handling, all parkings and loyalty data is retained between program sessions, ensuring no information is lost when the program is closed. Developing this project strengthens our understanding of programming and give us hands-on experience translating a real-world process into a functioning system.
So that's all from us. Thank you.